All right. Oh. Okay, so yesterday we learned a few things about quadratics. Today we're going to learn the other half. And again, you're going to be really happy about this because when we do conic sections, we look at four things. Circles, pretty easy, relatively. Parabolas, which are quadratics, hyperbolas, and ellipses. So circles, you actually learned a little bit about them already. You're going to learn a little bit more. But the parabolas, you're going to have everything you need to know right here after today that you'll need on this chapter as well as the next chapter we do. So you kind of get it double dip. Now, if you don't learn it on this chapter, then you've got two chapters that could harm you, I guess. But the only difference is next chapter we're going to look at all kinds of parabolas, even ones that go sideways. But there's very little tweaking in your knowledge that you need to do to be able to be in a good shape there. All right? Oh, also, I do want your homework. You don't have to give it to me right this second. I do want y'all's homework from last night, so you can give it to me a little bit later. Okay? So let's look at part 2 of quadratics. Y'all sure you're good? Right? So you know that the A value, if it's positive, what does it do? Open up. A negative opens down. You know that the lattice rectum is always what length?
1 over A.
Technically the absolute value, so make it positive, but 1 over A. So flip the A and you get lattice rectum. You know that the C value represents what? The distance between the vertex and the... Well, actually, if you have a point and a lattice rectum's aligned, there's all kinds of distances. Specifically, it's the distance between the vertex and what? The focus, right? The vertex and the focus, which is on the lattice rectum, right? So, and you find that C value by doing what? 1/4 of the lattice rectum, good. And then you can, what else did I want to ask you? And if the A value is something that is between -1 and 1, what does it tend to do to your normal size parabola? Widen it. And if your A value is bigger than 1 or smaller than -1 or gets larger, plus or minus, what does that tend to do with a normal parabola? Skinny it up, okay? Or make it thin looking. And trying to think of one else. Nope, we'll go with that. So we're going to add on to that the other part of quadratics. I call it quadratics part 2. And I believe you start on page 13 with this. So if you want to open to page 13 in your book, we'll jump on in there. And you're probably going to know some of this. But we're going to maybe have to tweak a little bit of the way you do things. Okay, so we got very comfortable yesterday with knowing how to graph when it was in this form, right? But I'm not going to give it to you in that form all the time. Or you're not going to have it given to you in that form. You're often going to be given it to, it's going to be given to you like a function. And granted, the A value there that you use for the quadratic formula is the same as the A value there. So you should be able to look at a graph like this and I go, hey, what's the length of the lattice rectum? You should be able to figure that out, right? Because if that's a 5 right there, you could go, oh, the length of the lattice rectum is 1/5. Or if A is a 1/8, you could say, oh, the length of the lattice rectum is 8. So remember, same A value, but you wouldn't know how to graph it because you don't know where the vertex is, and you don't know how to add or subtract to that vertex to get to the focus, etc., etc. So what can I do to change this into this? And the process is a process you already know. It's called completing the square. And it's been a few days, but do you remember how you took an equation like that was set equal to 0, and you completed the square? Yeah. You remember that process? And in that process, you ended up getting something like x minus, I'm making something up here, and then you ended up getting some number like 7 or whatever. You got it to this. And you'll notice it was x minus something squared. Well, my goal, in a similar way, is to get that x minus something squared in there. So it's a very similar process to completing the square, except again, my goal is not to solve for x like it was before. My goal is to make it look like this form. So there's one thing I'm going to do a little bit differently, and you'll see why in a second. But that's what I want to talk about first. So I'm going to walk you through one or two of these, see what you can do. So the example I gave you here is convert this function into parabolic form. Okay? So if I want that form, I'm going to have to do the process of completing the square. Now I personally like a y in there, not an f of x. So the first thing I do is I just change f of x to y. Okay, just because that's what it means. It just looks a little better to me. So I'm going to do that first. There's a y right there now. And then what was the first step in completing the square that you remember doing?
You subtract the...
You move the constant over, right? So if that's a y, I'm going to subtract that 7 to the other side, and now I'm right here. Now, do you remember the second thing that you did? And I told you it was really important that you did this before you completed the square.
Make sure A is 1.
Make sure your a is 1. And my a is not 1. Now, if you think back to what we did, and this, I don't know when this was, Thursday or Friday, I said just go ahead and divide that by that a. And when you divide it out, like if I were to divide by 3 there, and on the other side, that 3 would be gone, and I'd have x squared, and that'd be great. But the problem is I'm not trying to solve this time. I'm trying to make it look like this. And if I just divide by 3, I'm going to have y minus 7 over 3 over here. But if I think about what I want to end up with, I don't want to have something over 3. I want that a value to be there. So again, I have a different plan in place. So instead of dividing the 3 away, I'm going to do the next best thing, which is factor it out. And factoring it out is the same as dividing, but you're basically dividing by 3, but putting it out there to show what you just did. So if I were to divide that by 3, I would get x squared minus 4x. That's what I'm going to end up with when I factor the 3 out. And I like that because that ends up being the a value I need. You see it? But that is not a perfect square trinomial, is it? So this is where completing the square is. So now that that is factored out, it's like the a value, there's a 1 in front of the x squared now, and now that I have a 1 in front of the x squared, what's the trick to completing the square?
You find the B value by 2 and square.
So technically, you could argue that that was the b value, but you know what we're talking about, right? So if that is the value, take this, divide it by 2 and square it. So when I divide that negative 4 by 2, I get negative 2, but when I square it, I get positive 4. Now, why in the world would I add 4 here and balance it by adding 12 there?
Because you took out a 3.
Yeah, because I really didn't add 4 to this side. I added 4 to the parentheses. But what really is this if I go back and multiply it by 3? 12. So you have to remember, whatever I add on the inside might not be what I added to the entire right side. I really added 3 times that. So to balance out the math on that equation, I'm going to add 12 here. And that wasn't something I had to think about when I solved, because when I was solving, that 3 was never there, right? I divided it away. It was already on the other side. But you got to be careful there. That's a very common mistake. Forgetting to, people put plus 4 instead of plus 4 plus what it actually is, 12. And then what's the last thing we do once I complete my square? I just factor it. But remember the trick for factoring it?
But
Just drop the 3, but square root the x squared, square root the 4, sine of the middle term, quantity squared. And that's just a trick to factoring a perfect square trinomial. And you know it's a perfect square trinomial because you just what? You made it one. That's what completing the square is. You completed this perfect square trinomial. So you can always use that trick to get it factored, and then now we're in great shape. So what's my vertex? 2, negative 5. What's the length of my lattice rectum? 1/3. Probably not going to be very useful there, right? So I'd probably graph this using my cheap trick, right? I know the graph is going up because it's a positive a and you're on your way, right? Okay, so what if I tried it with a different function right here? Same thing as before. I'm going to change that to y just because I like that better, and then I'm going to do what? Subtract the 11. That jumps me to right here. Now I don't have a 1 right there, so what do I want to do? Factor out the negative 2. Now when I factor out a negative 2, again, remember it's like dividing by negative 2, so it's going to change the signs from negative positive to positive x squared negative 10x. All right? And then you complete the square. You can't change the order of this. You can't complete the square and then factor out a -2. You might think it works, but it won't give you a perfect square trinomial. You have to do it in this order. All right, so how do I complete the square of that?
Divide -10 by 2.
Which is -5, and square it is 25, and I added 25, but 25 is not what I added to that side. What did I add to that side?
50.
-50, so add a -50 to the left, clean it up, and you're on your way. You got a downward, kind of skinny parabola at the vertex 5, positive 61, right? And from there you should be able to sketch a graph, assuming your graph paper went to positive 61, and you should be able to find intercepts, find the length of the lattice rectum, do all kinds of different stuff from that.
So why'd you do that -2 thing where you made it 25 on one side and -50 on the other side?
Because right here, it's kind of like this. What if, I'm going to try to get there. What, is this a true statement?
Yes.
Is multiplying this by 4 a true statement?
Yeah, no.
No,
No.
because I didn't multiply the whole side, did I?
No.
Now, right here, it looks like I'm adding 3 there, but am I really, if I simplify this, this is really not 3, it's 4 times 3, isn't it? 4 times 2, 4 times 3. So a 3 added inside of a parentheses isn't adding 3 to that side, it just depends on what's out front. And right here, me adding a 25 inside that parentheses doesn't mean I added 25 to that side. It might, but because there's a -2 out there, this right side is really -2x squared, positive 20x, you knew that, but -50. So what the end result to that side was, 50 was subtracted, you gotta subtract 50 there to keep it in balance.
Okay, yeah, I got it.
All right? And it's very easy to forget that early on. The more you do it, and you'll do this a lot this chapter next, you'll get more comfortable with it, and that careless error, if it does happen, it will be careless, it won't be conceptual. All right, let me throw you a couple curveballs. What about this? So help me out. First step, you do what? Change fx to y. Great. Second step?
Put the 35 on the other side.
So add 35 to both sides. That cancels it on the right, makes it positive on the left. Next step, factor out a -4. So when I factor out a -4, that gives me a positive x squared. The 35 is already gone, right? It's already over here. And then factoring out a -4 out of -24 gives me a what?
Plus 6x.
Plus 6x. So I'm basically factoring out a GCF. Now I need to complete the square. So how do I complete the square here?
Take it in half and square it.
Half of that's 3, square it's 9, but did I add 9 here?
No.
What did I really add?
36.
-36, so I have to balance it with a -36. I'm keeping it balanced, right? It's math, it's algebra. So that gives me a y, -1, y minus 1, -4, and how does that factor? X plus 3 squared, and there's your parabolic form. The next one's a little uglier, so I want you to be careful. Okay, what would you do first? Replace that with a y, then subtract the 3 over. So from right here, the 3's gone. What would you do to this part? Pull out a -1/3. Okay, easier said than done for some. If I factor out a -1/3, that's going to leave me x squared here. But what's it leave me on the next term? Now, this is where you can just think for a second. It does leave you a 12. Think, how did I get from -24 to +6? What did you really do to -24? When you factor out a -4?
Times the reciprocal.
Yeah, you multiply by a reciprocal or divide it. So I would divide by -4 to give me 6. Well, dividing by a number is the same as multiplying by a reciprocal. Right here, to pull out a -1/3, I'm going to be dividing that by a -1/3. But what's dividing by a -1/3 same as?
Times -3.
Multiplying by a -3 gives you a +12. Are y'all seeing that? Now, if you're unsure that you did it right, couldn't I just do a quick check and distribute it back in just to see if I started? Right? That times that's negative 1/3 x squared. That times that, negative 4x. So I feel pretty good about where I am. Y'all seeing that? Because remember, to factor out, it's the same thing as dividing. So now, how do I complete the square?
Divide 12 by 2 and square that.
Which gives you,
36.
and when you add 36 over here, what am I really adding to that side? A negative third of that, which is negative 12. So if I'm adding a negative 12, I'm going to also want to basically subtract the 12 there too. Capiche? So y minus 15, negative 1/3, x, 6, sine of the middle squared. And again, if you're looking at that and going, what happened to the middle term? You didn't consider the middle term. I just memorized a rule for factoring a trinomial. I have somebody tell me all the time, when you do that, you're not even paying attention to this. And I go, what if that was a 13? I'm like, well, if it was a 13, then this would not be a perfect square trinomial. I would have ended up with a different number. This little trick I'm using is just the way to factor perfect square trinomials, if you know they are. And you know they are because you just created it, right? So you're good to go. So what's the length of my lattice rectum? 3, all right? What's my vertex?
Negative 6, 15.
So which way is it going? Down. So once you get it here, you can actually tell some stuff about it. Now I want to show you another trick. And this trick, I'm not advocating it necessarily because it's a memorization thing. And it's easy to forget stuff you memorize. But I kind of want to show you, and I'm going to, remember when I did that proof of where the quadratic formula came from? I wrote it out on this next page, so I'm going to kind of, or part of it, and I want to show you a little trick for finding the vertex. Because let me ask you a question. What if I said, put this in parabolic form, and you did not have the completing the square at your disposal? That's what I did here. So I'm saying, put it in quadratic form without completing the square. Well, I know that if it's y, I know that it's going to be y minus k, a x minus h, because that's my form, right? I just don't know the vertex, and I don't know what else. Oh wait, I do know a. I know a. It's the same as up here. So I've got the a value. So the only thing I need to know is the vertex. Now what if I told you there was a trick for finding the x coordinate of the vertex? Like what if I told you you could match, what did we get for the x coordinate? In this one. We had x, oh no, it's right there. So the x coordinate was negative 6. What if I told you that there was a trick, the vertex, which is hk, there was a little trick for finding h. And if I could find that h, which ends up being negative 6, how could you use that negative 6 to find the k value? Plug it back in. I could just take that, to find the k, I could just plug it back in my function, and we would find that the k value would be 15. And I would have my vertex. And then I could just plug the vertex right in here and call it a day. So the question is, how would I find that little trick for finding the x coordinate? Are y'all tracking with me so far? So if you look at your notes on the next page, the trick is, and I'm going to show you where this comes from, but again, if you want to do it this way, you can skip the step of completing the square, and you can, and if I ask you to do it to solve, I want you to do it to solve. But on problems like this, I don't care what method you use. But that's always, negative b over 2a is always ends up being the x coordinate of the vertex. It's the h. And if that's the h, and I could find that number, then all I got to do to find the k value of the vertex is plug that back into the function, whatever it is. Now, why does it work? Okay, check it out. I did the little math for you again. If I have a generic equation, okay, and I'm going to turn this into parabolic form. Follow with me if you're seeing this is the same thing as y. I'm going to subtract the c over, and I get to here. You with me so far? I'm going to factor the a out, and we just said to divide an a out, it's the same thing as, to factor it out, it's the same thing as factoring it out and then dividing it here. And that gives me x squared plus bx over a, right? Yes? Again, you're not gonna have to do all of this, but I'm just showing you to you. Then how would I complete the square? You would take half of this, half of that gives me b over 2a, and then what would you do? How do you complete the square? Well, then what would you do?
Square it.
Square it, gives you b squared over 4a squared, b squared over 4a squared. But I can't just add it here without adding it over here. So what did I really add over here? That times that, which would be ab squared over 4a squared, which means one of the a's would cancel, which is really b squared over 4a. But here's where it comes into play. When I factor this, what do I get? Square root of that, sine of the middle, square root of that squared. So what's my x coordinate?
Negative b.
Negative b over 2a. Well, you don't have to do all this. This is always true for any generic quadratic. So if you have a quadratic and you want the x coordinate of the vertex, all I have to do is go negative b over 2a. Well, guys, that's the b, that's the a. Go negative that over twice that, and you have the x coordinate of the vertex. Take that number, plug it back in for x, you have the y coordinate of your vertex. Now you have your vertex, take the a value, plug it into your equation, and you have your equation of a parabola. And you didn't have to complete the square because you're using knowledge of why the completing the square, what completing the square actually is doing. So let me show you. So right here, random function, right? Rather than going through the completing the square process, my goal is to fill out that equation. Now the easiest part is the a. The a is the same, negative 4, right there. How do I find the x coordinate of the vertex? Now remember, the x coordinate of the vertex is the h in the hk, right? What's the trick? Negative b over 2a. So negative 24, negative 24 over twice the a value. Well, there's 3 negatives, so it's negative. What's 24 over 8? So negative 3, that's my x coordinate. So x minus the negative 3, there's your plus 3. And then what do I do to find the y? Plug that to find the k value of the vertex, plug the negative 3, which is the h, into the function. So when I plug it back into this function, I get negative 4 times negative 3 squared, minus 24 times negative 3, minus 35, and I clean it up, and you can see negative 4 times 9 is negative 36. That's a positive 72, minus a 35. Do all the math, you get a 1. And the 1 is the y coordinate, y minus 1. And I didn't have to complete the square. Now you might look at this and go, that's not easier. I might agree. But sometimes you get problems like this, and this is another option that you might have. Y'all with me? And so right here, real quickly, help me out. We'll do number 6, and then, I'll tell you, we'll do number 7, and then you can do number 6. So number 7, I'm looking for this formula. What do I immediately know?
A.
A is negative 1/3. Okay? How do I find the x coordinate of the vertex, which is your h? H is
4.
negative what?
B to 4.
Negative
B over
b, so negative 4 over 2a. Now how do I clean that up? Clearly I have how many negatives? 3 negatives, so I know it's going to end up negative. And what do I do with a 4 on the top and a 2/3 on the bottom? How do I divide 4 by 2/3? So I'm going to multiply by 3/2, which gives me 12 over 2, which is, and don't forget the negative, so negative 6. So my h is a negative 6, that gives me x plus 6 over here. And then how do I find my k value?
Plug it back in.
Plug it back in. So I'm going to plug negative 6 back into my function, And I'm gonna do as much of this as I can handle in my head. So I get a negative 1/3. What's a negative 6 squared? Okay, and then negative 4 times a negative 6 plus 3. So what's a negative 1/3 of 36? Negative 12, positive 24, plus a 3 gives me 15. So y minus 15. Now that's a lot of math. And I honestly, completing the square might be a little easier, but it is another option for you. And you're essentially using completing the square. You're just not showing that you knew where this came from. Okay, we're gonna move on. Are y'all with me? Now, I'm gonna throw a couple of random things at you, and I'm gonna see if you can put it together as to what you would do to solve these equations. Because these are the kinds of equations you see at math tournaments, on my test. Now, granted, I will totally give you a function and ask you for all the little details like, what's the vertex? Which direction is it opening? What's the C value? What's the length of the lattice rectangle? I'm gonna ask you all those little things, and those are kind of easy little questions to answer if you know your rules. And then I'm gonna give you kind of these more broad strokes and ask you to take what you know and see if you can fill in the gaps. So look at example 8 right here. It says, find the function in parabolic form going through this point and having a vertex of this point. So I'm looking at number 8 right here. So ignore this junk right here. I'll come over here, number 8. Is there any part, it says the function in parabolic form. So parabolic form is this form. So is there anything right now that you know about this?
The vertex.
The vertex? Why don't I fill that in then, okay? So I know the vertex is 2, 7. So I have y minus 7, a x minus 2 squared. So I really just need this a value, don't I?
Yes.
Now, what does that other point represent? It represents one of the zillions of x's and y's, right? So anybody got an idea what I could do with that x and y then? Now, when I plug it in, what is my goal of doing that? Because in the equation, I really don't want it there. Right? Right. It lets me solve for a. And any point that's actually on this parabola, if it's on this exact parabola, will give me the same a value. Right? Because the a value is what controls the behavior, right? The sign of it controls up or down. The size of it controls the shape of it. So as long as I give you a point that's on this one, I'm going to get the same a. So I'm going to borrow this point, negative 3, 5, for the moment. Negative 3, 5. And I'm going to solve just to find a. So what is my a value?
A goes negative.
Negative 5 squared is 25. So what's a? Negative 2 over 25. So I'm going to use that a now to go back and plug it in. But don't plug it in here, right? I want an equation that has an x and a y in it. So I'm using that point that's not the vertex as one of the many points that are on here to help me find a, but once I get that a, negative 2 25ths, that is the actual equation of the parabola. And if you're in doubt, take these points, plug them back in there. You should get a true statement every time. You plug it in the left, plug that point in for x and y, and you'll get like 10 equals 10, or 4 equals 4, and 0 equals 0, or something that's true. All right, what about this one? It says, find the function in parabolic form, which has x-intercepts at negative 2 and 8, and has a max at 4, or the max is 4. Has x-intercepts at negative 2 and 8, and a max is 4. Is there anything right now that you are feeling?
You know
It's going down. How do you know that? You got 2 x-intercepts, and there's a what? A max that's higher than that. So the only way for that to happen is for it to go down. That's great. So you know the a value is going to end up being negative. What did I just do in describing that?
you told us where the vertex was. Or you told us that y equals negative.
Yeah, that's even a better answer to my question. What I'm really trying to say is I'm visualizing this. So for you to sketch this really might be helpful. But yes, by giving you this information, I am guiding you right towards the what?
The vertex.
The vertex, because check it out. if I'm sketching this right here, this is now number 9. If I have a graph, and I know that the x-intercepts are -2 and 8, so let's just say that's a -2, and that's an 8, and I know that I maximized at a height of 4, so let's just say this is 4. So if I'm going to hit that and hit that, you know that there's symmetry on the parabola functions that we're dealing with. Our parabolas aren't doing this, are they? They don't go sideways. Ours are just going up or down. Is there any way to make this parabola go up?
Yes. Oh, no.
Not if there's a max, right? It has to hit there. And didn't we say, maybe yesterday, I might have not said it in this class, I might have said it in the other, but isn't the max always end up being what?
The y coordinate.
The y coordinate of the vertex. Because the vertex is where that max or maybe that min occurs. So if I give you a max or min, I'm giving the y value of your actual vertex. So if I have a max of 4, you know right now that the y coordinate of your vertex is 4. It has to be where? Where is it? Is it right there?
It has to be in the middle, so.
It has to be in between those because of symmetry, right? So if it has to be in between, I know that my vertex is right there at what 4? Well, how would I find what's in the middle of that? You can average them. So 8 and a -2 is 6. 6 divided by 2 is 3. And you could just say, oh, the total is 10, so go 5 from each way. But that's not easier. Just average them, right? Add them together and divide by 2, and you get 3. So I must be right there at 3, 4. So great, I've got my vertex. I'm almost there. Check it out. Y minus 4, a x minus 3 squared. What am I still missing?
A.
Now let me show you what a ton of people do wrong right here. They go, oh, I know my latus rectum's 10. It's tempting to look at this and go, oh yeah, that's my latus rectum right there. And that's a length of 10. And that must be the focus right there. Is that true? Could be. How can you tell if it's true or not true? If it was true, the length would be 10, right? What's the distance from the vertex to the focus? If that length is 10,
4 times.
it'd be 2.5 because it's a fourth of it. Is that length 2.5?
No.
Then that's not the latus rectum. So I can't say, oh, 10. That would make a 1/10, but negative because it's going down. Y'all see how easy it is to make that mistake? I see that all the time. So what would I do to find A? We technically just did it in a problem right before this. Plug in another point. Now I don't want to use the vertex, because if I plug the vertex in, I get 0 equals 0. Does that make sense? Like if I've already used the vertex. Is there any other point you know?
0 and -2.
-2, 0, or 8, 0? Your choice. I kind of like 8, 0 because there's no negative there. But if I plug an 8 there and a 0 there, I get -4. 5 squared is 25, so A is -4/25. And it does the math for me. It gave me the A. Oh, it was negative, sure enough. And now I can take that and plug it back in to this. You tracking with me? But sketching a little picture when you're in doubt is a pretty good idea. And even if it's not a good idea, how much time have you spent? I mean, not much. All right, what about this? Determine the max, min, domain, and range of the following parabolas. Now, what do I need to know about max and min?
It's opening.
The vertex's y value and which direction it's going, right? So I know the vertex is 5, -4, and the graph is going down on this first one. So that vertex right there, will this graph have a min? And I know the temptations go, oh, it's going down forever, the min's -infinity. But what do we say about a min? Min is short for minimum y value. And a value has to be an actual number that you can tangibly see and touch and feel, not a concept like unbounded forever and ever and ever, right? It's just not a number, it's not a value. So if this graph goes down forever, is there a min? No. So for the max, I can answer that. What is the max? Is the max the vertex? No, because max means maximum y value. So the max would be the -4. The min would be does not exist or no min. And then domain. Look at this graph. And by the way, this is true for every parabolic function. What's the domain of a graph like this? Which means which x values does this graph have? All of them. I mean, I know it's going to start going down real steeply, but isn't it still moving out? I mean, can't you still plug in a -1,000 in here and get an answer? Or a +1,000 and get an answer? Or a -1,000,000 or a +1,000,000? You're still going to get an answer, right? Every value of x is true here. So the domain is always what? All real numbers. Now, the range you got to think about for a second. What is the range of a parabola that's going down? Everything under the vertex. So how would I say that? We're talking about range means x values or y values? Y values. So couldn't you say all the y values that are what? Less than or equal to the -4? And if you use interval notation, how would you write that? How do you use interval notation to show everything smaller than a -4 or equal to a -4? Negative infinity, comma, -4 bracket. Great. And by the way, please don't miss domain on these. On this test, the domain is always all reals because they're always going either up or down, so they're always spreading out left and right. The range may change because sometimes it's below -4, sometimes it's above, depending on which way it's going, but don't miss that. Okay, what about this next one? So I need to know the vertex again, which would be -1, 3, and which way it's going, and this one's going up. So let's run through these again. What would the max be? D and E. Why? Did y'all all hear that? Because my graph is opening up, it's going up forever. I don't say infinity because there is no maximum single y value bigger than all the rest. It's just unbounded in that positive direction. So max, none, or D and E, or no max, whatever, does not exist. What about the min?
3.
3, not the vertex, but the y value of it, right? So the min is 3, and you don't even have to say y equals 3. Just 3 is fine. And if you get that down now, man, I still struggle with half of my AP kids are from a non-math team group, and that doesn't mean they're weaker. I mean, some of the smartest ones in there are from non-math, and they just never wanted to do it in the middle school because they were too controlling over there. So they never got back in the swing of things here, but they're still really great. But they struggle with that max and min thing, saying y equals or saying the vertex because they didn't get pounded in 10th grade. So make sure you kind of think of that correctly. It's always a y value for these. And then the domain, all reals, as long as it's a function. Now, when they start going right or left, that's not going to be true, but that's not in this chapter, right? So domain, all reals, and range.
Y is greater than or equal to 3.
So the easiest way is probably to say y is greater than or equal to the min, because it's going up. But if I used interval notation, what would it be? From what? Bracket 3, comma, infinity. Because I always want to go least to greatest when I write interval notation. So least to greatest, least to greatest. Not too bad. Easy day. All right, so I've given you part 2, quadratics. That's Tuesday. Tomorrow will probably be what most people consider the toughest day, because tomorrow we're going to be writing quadratic functions and actually looking at some word problems, and it's a little trickier, although not a ton. And then we're going to review Thursday test on Friday. All right.
Smell that? What's that smell?
Yeah, just the homework that was due today is all I need.
There's a stench. Every single day, Isaac and Ryan would do it.
Not the homework, it was a real.